Hi everyone, so here we're going to talk about the last part of nuclear chemistry, which is the uses of radioactive isotopes and why they're so important in everyday life. So you'll need your notes for this, and this is pretty much memorization. We're going to talk about uses of radioactive isotopes in dating and medical uses, as tracers, industrial, and in food. So for radioactive dating, we can check the age of once living material like plant matter or dinosaurs or whatever by using the ratio of carbon-14 to carbon-12. So if we take a look at table N, you can find carbon-14 right up here. It's about 5,715 years for it to decay in half. So if you have 100 grams of it, it takes 5,715 years for it to decay by 1/2. That's pretty recent in terms of the whole time scheme of the Earth. So we can use carbon-14 to help us figure out, again, anything that was once living. For anything that deals with rocks or geological formations, we use uranium-235, which is all the way down here. The half-life of that is 7.04 times 10 to the 8th years. That's a pretty long time. But that's how we can use, or what we can use to check to see how old certain rock and, again, other geological formations are. So we use the ratio of uranium-235 to lead-206. For medical uses, we want them to have short half-lives and be able to be quickly eliminated from the body so they're not stored in any fatty tissue or anything like that. So the shorter the half-life, the better, because, again, we don't want it to be in our system for very long. So if we look at iodine-131, its half-life is 8.021 days, right there. So iodine-131 can be injected into the body to detect for any thyroid issues. Cobalt-60 and technetium-99. So let's see, cobalt-60 is right here. 5.271 years, not necessarily that great, but that's actually used to treat tumors so that we can pinpoint that towards specific tumors and kill them. Technetium-99 is also used to treat and detect tumors as well. Chemical tracers. So pretty much if we're trying to figure out the process of cellular respiration in a certain plant, we can use, again, carbon-14 to help us figure that out, because carbon's a vital source in cellular respiration. Again, we start out with carbon dioxide, water, and all that, and produce glucose, or we don't, but plants do. Phosphorus-31, we can check to see how that's going to be, or how phosphorus is taken up by certain plants. So we can kind of use that in terms of, or why that helps is like, phosphorus is a major component in fertilizer. So we can check to see how that fertilizer is being used throughout the plant. And for industrial uses, we can actually use radiation to help us figure out the strength of certain welds. And welds are pretty much when you have two pieces of metal fused together. So for example, when you're in school, take a look at your desk. Look at wherever there's two pieces of metal together, you'll see like there's like this little kind of like bubbled area around it. That's what a weld is. And it's really important, maybe not so for a desk, but maybe a bridge where thousands of people are traveling over it every day. We want to make sure that that weld is very stable and that bridge doesn't collapse. For food, we actually use radiation to kill microorganisms on any food, especially if it comes in from a foreign country, just to make sure it doesn't bring in any more pathogens into the U.S. So some questions here. What is the most abundant isotope found in a naturally occurring uranium deposit? So we want to make sure that we figure out which one ends up being the most abundant again. So we'll actually end up picking whichever uranium that we saw before, right? So this is memorization. Can't really help you much out with that. But we saw uranium-235. So that was the one that was naturally occurring in deposits, or most abundant. The radioactive isotope I-131, or iodine-131, is used in, and remember that was for thyroid, so that should be a medical diagnosis. And which isotope can be used as an organic tracer? Anytime you think organic, just like back in bio, we want to think about carbon. So here we have carbon-12 versus carbon-14. Which one's radioactive? Carbon-14 is actually a radioactive one. Alright, so again, unfortunately this is memorization. Just know each of these uses and you'll see them. If you see one of these questions, do a happy dance because it's something that's easy that you guys can answer. Have a great day.